This video is an example of a hypothesis test for a population mean using the confidence interval method. In a study of the effects of prenatal cocaine use on infants, the following sample data were obtained. The sample size was 190, the sample mean was 2,700 grams, and the sample standard deviation was 645 grams. Use a 99% confidence interval to test the claim that the weights of babies born to cocaine users have a mean that is different than the mean of 3,103 grams for babies born to mothers who do not use cocaine. Now, because the sample size is more than 30 and the population standard deviation is not known, I'm going to use a confidence interval from the t-distribution. First, I need to set up the null and the alternative. The claim is that the mean weights are different than 3,103. So in terms of the population parameter, that would be mu not equal to 3,103. Okay, so different would mean not equal. This makes the statement the alternative hypothesis. So the null is mu is equal to 3,103. Now the statement mu not equal to 3,103 would imply that cocaine affects birth weight. Okay, so to extend this problem, if we were ending up to reject the null, we could safely conclude that cocaine affects birth weight. That's what that alternative statement represents. Now, I've done a previous video on how to find a confidence interval using the t-distribution or a t-interval. I'm going to go ahead and use my TI-84 to do that. So you want to go to your stat menu, over to tests, and down to the t-interval. If we knew the population standard deviation, then we would be using the z-interval. It's nearly the same procedure. We have the summary statistics. The sample mean in this problem was 2,700, and the sample standard deviation was 645. The sample size was 190. Whoops. 190, and the level of confidence is 0.99. Alright, so the corresponding 99% confidence interval for the population mean goes from 2,578.2 up to 2,821.8. Okay, so that's a 99% confidence interval for mu. The confidence interval represents the mean birth weight for babies born from mothers who use cocaine. Now, to reach a decision based on the confidence interval, we need to look at this confidence interval and determine, what does this interval blanket? Does it blanket the case of equality from the null? In other words, is 3,103 captured in this interval? Well, it does not. The entire interval is actually below the mean for babies who are born from mothers who do not use cocaine. So that indicates that cocaine is affecting birth weight. And looking at this confidence interval, it appears that the average birth weight is less than that of mothers who, babies of mothers who do not use cocaine. My apologies. This is a tongue twister for me today. So the decision based on the confidence interval is to reject the null. And the correct way to say that is that there is sufficient evidence to support the claim that the weights of babies born to cocaine users have a mean that is different than the mean of babies born to mothers who do not use cocaine. So again, your confidence interval will help you decide whether you're going to reject or fail to reject the null. You need to look at your interval and see, what does it blanket? Does it blanket the null statement, or does it blanket the alternative statement? This one clearly supports the alternative in this particular problem.